today's problem from pair of straight line, and the problem is show that the four straight lines given by the equation this and this forms a rhombus. Okay, we first write the first pair of straight line. This is y minus mx whole square. This is equal to c square into 1 plus m square. We name this is 1. Clearly this line represent, or this pair of lines represent two pair of parallel line, because each of the form y equal to mx plus c1 and y equal to mx plus c2. Into the two lines only constant are different or other term are equal. So this represents a pair of parallel straight line, and we write this is given by like this is equal to 0. And similarly we say that the second pair is also a parallel pair of straight line, which is written as y minus nx minus c square into 1 plus n square. This is equal to 0 and this is 2, right? And since these are two parallel and these are also two parallel, so these four lines must form a parallelogram. Okay, since these are two parallel line and these are two parallel line, and if we draw the rough sketch of this parallelogram, this is looks like this. Okay, this is A, B, C, D, and AB and DC are represented by, we say 1, and we write here AB plus DC, and AD and BC are represented by the line 2. This is 2 and also this is 2, and this is AD plus BC, right? Now to show this parallelogram becomes a rhombus, because we have to show that these four lines forms a rhombus. We have to show that the diagonals BD and diagonals AC are perpendicularly bisect, because we already know for any parallelogram the diagonals are bisected, and we have to only show the diagonals are perpendicular. That is, we proved the perpendicular bisector of each other, then this parallelogram becomes a rhombus. Okay, so we have to show that we have to prove only AC is perpendicular to BD, right? Now A, B, C, D, these are the point of intersection of this given four lines. Okay, here A, B, C, D are the point of four intersection of pair of lines 1 and 2. So we can write any equation passes through the point of intersection of 1 and 2 as, we can write this is lambda into equation number 1 plus mu into equation number 2. This is equal to 0. That is, we can write this is lambda into, the first line is y minus mx whole square minus c square into 1 plus m square plus mu into the second line is y minus nx whole square minus c square into 1 plus n square. This is equal to 0 for lambda mu belongs to R. This is the set of real number. So we have to put lambda this is equal to and mu this is equal to. What is the value of lambda? We put here any real value of lambda. We put here lambda this is equal to 1 plus n square and mu this is equal to minus 1 plus n square. Okay, so we get the equation of pair of diagonals of the parallelogram. That is we get pair of diagonals of ABC as. What is the pair of diagonals of ABCD? Which are AC and BD and can be written as, we put the value of lambda is 1 plus n square into y minus mx whole square minus c square into 1 plus m square minus this is 1 plus m square into y minus nx whole square minus c square into 1 plus n square. This is equal to 0. And if we multiply this and this both, it is clear that this term and this term be cancelled, and the equation becomes 1 plus n square into y minus mx whole square minus 1 plus m square into y minus nx whole square. This is equal to 0. This represent diagonal AB. Sorry, this is diagonal AC and B. Right. Now, if we find out the coefficient of x square plus coefficient of y square. What is the coefficient of x square? Coefficient of x square is clearly this is m square into 1 plus n square minus 1 plus m square into n square. This is the coefficient of x square of whole term. And now we add the coefficient of y square. What is the coefficient of y square? This is given by plus 1 plus n square. This is 1 plus n square minus 1 plus n square. Right. Now this given by m square plus m square n square minus n square minus m square n square plus 1 plus n square minus 1 minus m square. Okay, and this is cancel out, and also this cancel out, also this m square and this cancel out, so equal to 0. And if the coefficient of x square plus coefficient of y square for a pair of straight line be 0, then this pair must be perpendicular. Okay, so we write here this seems coefficient of x square plus coefficient of y square, this is equal to 0, so AC must perpendicular to BD. Okay, that is two diagonals are perpendicular. So this parallelogram must be a rhombus. Okay, very interesting and easy problem of pair of straight line. Thank you for watching.